let's find the absolute maximum and the absolute minimum of the function f of x equals negative x squared plus 6x minus 2 on the closed interval 2 to 5. First of all, this function f is continuous. In fact, it's a polynomial. F is continuous everywhere, but the place we need f to be continuous is on the interval 2 to 5. Of course, f is continuous on more than that x interval, but we'll just cite that, call it a day. We are going to need to find critical numbers of f. So first, let's find partition numbers of f prime. So differentiating one term at a time, negative 2x using the power rule, plus 6. Now f prime is always defined. We should figure out where is f prime equal to 0. F prime is 0 when, well, let's take this negative 2x plus 6 and set this equal to 0. You have some options. You could factor out a negative 2 if you like, or just add, we just have a simple equation to solve. If you add 2x to both sides, 6 is equal to 2x, so x is equal to 3. So this means that so x equals 3 is the only partition number of f prime, right? Because f prime is always defined, so you didn't get any partition numbers from that part. If you were to draw a sign chart, the only x value to label would be 3. Now remember, to be a critical number of f, you should be a partition number of f prime, okay, so like this 3, but also in the domain of f. But f is defined everywhere. So that means that x equals 3 is the only critical number of f. So keep in mind the distinction, okay, partition number of f prime, and then of those, some of them are critical numbers of f. Notice there's no prime. Now the thing to do is to take this x value of 3 and apply the function f, and then also find f of 2 and f of 5, because those are the endpoints. Okay, absolute max or min might occur at an endpoint, and so all we have to do now is plug in right here, negative 3 squared plus 6 times 3 minus 2. Okay, so that's like 18 minus 9 is 9, minus 2 more is 7. And then f of 2, so negative 2 squared plus 6 times 2 minus 2. So that's, we've got 12 there, minus 4, that's going to be 8. And then subtract 2 more, and that's going to be 6. And then finally f of 5, so negative whatever 5 squared is, plus 6 times 5. Minus 2 again, so we've got 30 minus 25 is 5, minus 2 more is 3. Now we just have to report, right? So based on the information we have here, we've got to look at the biggest y value and the smallest y value. Do not compute f prime of 3. Actually, we know f prime of 3 is 0 by solving this equation, but don't compute f prime of 3. Don't compute f prime of 2. Don't compute f prime of 5. We don't need the slopes of these tangent lines. We just look at these y values and just say that f has an absolute or global maximum of 7 is the biggest y value here at this x value of 3 on this interval to 5, and then f has absolute minimum of the smallest y value here is 3, and this occurs at the x value of 5 right here on this interval to 5. So it looks like our absolute minimum, sorry for the poor handwriting, the absolute minimum occurs at the endpoint, at the right endpoint of 5, and then in the middle, somewhere in the middle between 2 and 5, at the x value of 3, that's where the biggest y value is found. And though we're done, let's just go ahead and graph this just to see what this looks like. So using Desmos, I get a graph that looks like this. Of course, in red is the overall function, and then in blue I've just highlighted the relevant part of the function that we're looking at. So, whoops, there's this point. Whoops, well, I lost that. So we'll just have to kind of go back and forth here. So the absolute maximum of 7 occurring at the x value of 3, that's this point right here. Okay. And then we should look, well, I'll just recopy this, just make this work here. So we're looking at this for x values from, what was it again? Between 2 and 5, so 2 less than or equal to x less than or equal to 5. Okay, maybe green is not such a great color, so I'm going to change this real quick to be blue. Okay, So on this blue graph, we've got this point 2 comma 6. So we discovered this y value of 6 already, but this is not going to be the smallest. The smallest y value is going to be right here. Smallest y value of 3 when the x coordinate is 5. Is that what we had? So we had absolute maximum of 7 at 3, absolute minimum of 3 at 5, and then, yeah, we computed f of 2 is 6, but we didn't need that number, right? So those are the numbers that we see here. F of 3 is 7, f of 2 is 6, and f of 5 is 3.